guys. Alright, so this is the video for section 7.1, day 1. This video is meant to be your homework for tonight. You need to go through it, pause and play as needed, take notes along with it as you would in class, and then tomorrow in class you're going to have the opportunity to ask questions. We'll go through extra examples if you feel like you need it, and then you'll be able to work on your math Excel assignment in class. Alright. So, law of signs. Law of signs is something that you did back in Algebra 2, so hopefully this should be a little bit of review for you. What we've done so far in our class, we've only solved triangles that are right triangles, and if we don't have a right triangle, we're not able to use our SOHCAHTOA ratios, so we need some other things to solve with. What we're going to be dealing with in this section and the next few sections are oblique triangles, meaning a triangle that does not contain a right angle. You'll remember in geometry you saw a bunch of these abbreviations for pieces of information you were given in a triangle. For example, if I see ASA in geometry, you probably call that angle, side, angle, and it meant if you were given an oblique triangle, you knew the angle, the side, and the angle as you rotated around the triangle. Or maybe if I was given a side-side angle triangle, that meant as I rotated around my triangle, I had a side, and an angle. So that represented whatever your given information was. We're going to use law of signs. Law of signs can be used to solve any oblique triangle or right triangle for that matter. If you are given angle, side, angle, angle, side, or side, angle. So from this slide, that's probably the only part I would write down, the part at the very bottom here, that law of signs can be used to solve angle, side, angle, side, or side, angle triangles. The other cases we're going to be using with law of cosines, and that'll show up in section 7.2. All right, law of signs. Here's our law of signs. I need you to make sure it's somewhere in your notes you write down the 3 ratios at the top that make up the law of signs, and I also want you to draw this kind of general triangle we've got on the side here. Notice a couple things about both of these. The capital letters are our angles, the lowercase letters are our sides, and then a pair of opposites in our triangle, a side and an angle that don't touch, use the same letter. So angle A and side A are opposite, angle B and side B are opposite, angle C and side C are opposite. And that's helpful to know because our opposite pairs make up the ratios in our law of signs. Sine A over A, sine B over B, sine C over C. You can see in the ratios up top, the angles are uppercase and they're with our signs, and then the sides are, again, lowercase and they're down in the denominators. When we use the law of signs, we will only ever use 2 of the 3 ratios together. So when we set it up, it's going to look like a proportion, and because it is a proportion, we will be able to cross multiply to solve for either our angle or our side, whatever's missing. When you set it up, you should be able to fill in 3 of the 4 variables, 3 of the 4 pieces of information, and have 1 variable left that then we will solve for. All right, go ahead and pause the video, get all this in your notes. When you're ready, you can push play, and on the next slide, we'll move to the first example. All right, here's our first example of law of signs. This happens to be a angle, side, or side, angle triangle, depending on which way you want to look at it. We don't have to remember those 3 little cases, though. How I like to think about law of signs is if I can find 2 pairs of opposites, I have enough to set up my ratios. For example, here I'm solving for y. Side y is opposite 145 degrees. They're not touching. 12 degrees is opposite the side that's labeled 13. They're not touching. Those are my 2 pairs of opposites, and within those 2 pairs I have 1 variable. That means I can solve using the law of signs. Setting it up, it doesn't matter which pair you use first, so let's say I choose to use 145. I just need to make sure the side that's opposite y is underneath it. Other ratio in this case will be sine 12 over 13. To solve, we're going to cross multiply. So that's going to look like 13 sine 145 equals y sine 12, and then we're going to divide by sine 12 on each side. And this is the part now where you're going to put this in the calculator. You're going to do 13 sine 145 divided by sine 12. Before you put it in the calculator, though, please make sure your calculator is in degree mode. You can type this in all at once. Just make sure you end the parentheses after the 145, or you could use your alpha y equals even here to set up that fraction. Typing it in, you're going to get 35.86. If I round it to 2 decimal places, will be the solution for y. So just double check that you can get that answer okay. Example number 2. This one says solve the triangle. Solve means find everything that's missing, all sides, all angles. So we have a side y that's labeled already. Let's call this guy over here side x. You can call it whatever you want. And then we're also missing an angle, so I'm going to call my angle theta. So x, y, and theta are what I'm solving for in this problem. If you're given 2 angles of a triangle, the next easiest thing always to find is that third angle. We know that all 3 angles in a triangle add to 180. So if I take 180, subtract the 2 angles that I know, in this case I'm left with 110, which solves for theta. Alright, so now I'm going to have to solve for x or y first. It doesn't matter. Let's say I want to solve for x. X is opposite 20 degrees, so that makes up my first pair. I need one more pair of opposites to be able to use the law of sines. I don't want to use 50 and y because that would introduce another variable into my equation. I want to use 110 and 15 because they're both known values. So that's going to look like sine 20 over x, sine 110 over 15. Cross multiply to solve. 15 sine 20 equals x sine 110. And then you're going to divide by sine 110 on each side in your calculator. And again, here we'll round to 2 decimal places. So 15 sine 20 divided by sine 110. I'm going to get 5.46 if I round to 2 decimal places. All right, solving for y. Y is opposite 50 degrees, so that's going to make my first ratio, sine 50 over y. And then I need another pair. We actually know x already, but x is a value that we had to round, so I'm going to kind of stay away from that one. I'm going to use 110 and 15 for my other ratio because I know those are exact. So sine 110, again, over 15. Cross multiply to solve, so it's going to be y sine 110 equals 15 sine 50, and then again we're going to divide by sine of 110 on both sides to solve here. So 15 sine 50 divided by sine 110, and I'm going to get 12.23. And then one kind of interesting thing to check, if you remember a property from geometry, it said that in any triangle, the largest angle is opposite your longest side, and the smallest angle is opposite the shortest side. So you can double check that here. 110 is the biggest angle, 15 is the longest side, 50 is the next largest angle, 12.23 is the middle length side, and then 5.46 and 20 are my smallest angle and smallest side, which are opposite one another. So that's kind of a nice, easy way to check. At least make sure your triangle makes sense and your calculators or your calculations are reasonable for the problem. Okay, take a few minutes. I want you guys to try these 2 on your own. So let's label everything here that you need to find real quick. So here we're just going to solve for side BC, which is this guy. So in the top problem, you were only solving for that side length x. The bottom problem, again, it says solve the triangle. So you're finding everything that's missing. So here, if I'm using the angles that they're giving me, I need to solve for side J is missing. So I'll use a lowercase j. Side L is missing, and then you also need to solve for angle J in this bottom problem. All right, again, pause the video, try it on your own, and then when you're ready, go ahead and hit play, and your answers will appear, and you can check them. Okay, here are the correct answers if you want to check your work. For the top problem, side BC is what I'm solving for. In order to get that and get my 2 pairs of opposites, I needed another angle. So I went ahead and did 180, take away the 2 I have. I got 67 degrees, and that allowed me to find 2 pairs of opposites. So setup is sine 85 over x equals sine 67 over 9. Cross multiply, and your correct answer for that side BC, which I labeled X, is 9.74. On the bottom, again, first thing I did was over to the side. I took the two angles I knew, took them away from 180, and I got the missing angle J is 43 degrees. And then I had to do a law of sines twice. I did my L's, sine 100 over L, and then my K's, sine 37 over 12. And then I cross-multiplied that to solve for L. I ended up with 19.64. And then to solve for J, sine 43 over J, and then again I used my my K's here, sine 37 over 12, because those were nice pretty numbers that I knew weren't rounded. Those were given pieces of information. Cross multiply to solve, and you should get J is 13.6. So go ahead and pause it, check anything you need to look over here, correct anything in your notebook, and then when you're ready you can go ahead and push play and we'll move on to the next problem. Okay, this is going to be our last problem in this video. A ship sailing due west at 25 miles per hour records the bearing of an oil rig at north 55.4 degrees west. 2 hours later, the bearing of the same rig is northeast 60.4 degrees. Okay, so we need to draw this picture. We know it's going to make a triangle shape. Let's start with the direction the ship is going. The ship is sailing west, and both times it sees the rig, it sees it to the north, to the northwest, to the northeast. So I'm going to draw my ship kind of on the bottom of this picture. So it's going to start here, and it's sailing to the west. If you remember your cardinal directions, maybe we'll stick that up here, north, south, east, west. So it's sailing from the east to the west. Okay, so it's its start and end point. First thing I notice is that it's sailing at 25 miles per hour, and it sails a total of 2 hours. So I can take those two pieces of information, 25 and 2, multiply them together, and I know that my ship has sailed 50 miles. So it's going to end up being one side of my triangle. All right, first time that the ship looks at the rig at its first location, so right here, it sees the ship at northwest 55.4 degrees. So northwest direction is this guy, so we'll label, I guess, O up here for my oil rig. Now the tricky thing about these directions is when we say northwest, it means from the north to the west. So this angle here is that 55.4 degrees rotation. Then the ship sails its 50 miles, 25 miles per hour for 2 miles, and then it sees the oil rig northeast, which now is this direction. So I'm going to label my angle from the north to the east, 60.4 degrees. So I can squeeze my degree symbol in there. I am solving for how far is the ship from the oil rig the second time. So that would be the second sighting, and I'll label that an X. First thing I'm going to have to do in this problem, 60.4 and 55.4 are not inside my triangle, but they're going to allow me to get these angles on the bottom. Because the ship is going directly east to west, we know that that's a cardinal direction, and then the dashed lines I have are north. So we know that these angles, 60.4 and then the other single one I drew, 55.4 and the other single one next to it I drew, add up to 90. So a really easy way to get them is just find the complementary angle. 90, take away the angle you have. So if I do 90 minus 60.4, I end up with 29.6 is this angle. And I'm going to do the same thing on the other side. 90 minus 55.4 gives me 34.6 degrees. Solving for X, it looks like I have two angles. So I'm going to go ahead and find that third angle, 180. Take away the two angles I know. Take away 29.6, take away 34.6. I get 115.8. And now my two pairs of opposites. It looks like X is opposite 34.6 and 50 is opposite 115.8. That's going to set up my law of sines. So sine 34.6 first over X, sine 115.8 over 50. Cross multiply. X sine 115.8 equals 50 sine 34.6. And then I'm going to divide by sine 115.8. I'll do this all on my calculator now. 50 times sine 34.6 divided by sine 115.8. And I get 31.5 here. It's a distance. My ship was sailing in miles per hour, so this would be 31.5. I'll label it miles, is that length x. Second part of this problem. How close did the ship pass to the oil rig? So we can agree that kind of where it started and where it ended, those were at an angle, so those were a little bit further away. Those were not the closest that it got to the oil rig. It got to the oil rig, closest distance between 2 points is a straight line. Got to the oil rig somewhere in the middle here, where I can drop an altitude down in the middle or close to middle of this triangle, and whatever that point is, that distance is the closest. So you can see here, if I drop an altitude down, I actually form two right triangles. And if I have a right triangle, it definitely makes it easier to solve. What you want to be careful about here is we don't necessarily know, and actually we can see here that it is not going to split that triangle right down the middle because we don't have an isosceles triangle. That 29.6 and the 34.6 are different angles, so this triangle, although my drawing is a little deceiving, is skewed one direction or the other. I can pick either right triangle to deal with in this problem. I'm going to choose the one on the left because I know that side x that we solved for, so I know a little extra information about it. So I'm just going to redraw the left side of this triangle. Here's my right angle. I know for sure x was 31.5. I know the bottom angle was 29.6. And we don't know how that 50 was split, so I can't label the bottom. And we also don't know how the 115.8 was split, so I can't label that top angle. We are solving for how close the ship got to the rig, so I'm going to call that y, the altitude of the original triangle. You can use law of sines again here if you want to. 31.5 is opposite 90 degrees, and y is opposite 29.6. So I'm going to go ahead and set that up. Because this is a right triangle, you could also use SOHCAHTOA ratios, and you're going to end up with the same answer if you feel comfortable doing it that way. But let's do another law of sines because that's what we're practicing. Sine 29.6 over y, sine 31.5 over, oops, don't do that, sine 90 over 31.5. Cross multiply to solve. 31.5 sine 29.6 equals y sine 90. And then you're dividing by sine 90, which is actually just equal to 1 here. So you can, if you want to, just put 31.5 sine 29.6 in your calculator, which is the same calculation you would do if anybody's doing the SOHCAHTOA ratios. You'll see that's the same thing. 31.5 sine 29.6 is the calculation. And I end up with 15 point, if I give it one decimal place here, 655 in my calculator. And I would label it miles. So that's the closest that the ship got to the oil rig. Okay, so that is the end of this 7-1 Day 1 video. You are all set now to complete the 7-1 Day 1 Math XL. This assignment, let me double check our calendar real quick. Will be due by midnight on April 17th, which is next Wednesday. Okay, so make sure you have all these notes written down. You don't have to do anything else at home. If you want to get started on your Math XL, if you're super excited about it, go for it. Otherwise, just make sure you bring your Chromebook to class tomorrow. And any questions you have over this video, we'll talk about those first, and then you'll have some class time to work on this Math XL assignment. Thanks, guys.